Thank you for coming my presentation. And today I present the power of the specific emotion analysis in predicting donation decision. Before I start my presentation, I want to share my personal motivation, how I start my research. I stayed in the New Zealand and my wife worked at New Zealand primary school and she teach the autistic student. And she sometimes complain about this autistic student have a difficulty to communicate with others because they cannot understand others' emotion. They are likely to focus on themselves. So I thought maybe I can make an emotion translator like a Google Translator, and they can see others' emotion by using smartphone app, and they can see others' emotion when you talk some conversation. They must be happy or they must be sad, and it can help them to communicate with others. And that's the motivation of my research. So this is my PhD thesis, and my thesis combined with 3 papers. And first 2 papers already published in IEEE and the Neurocomputing Journal. And then I briefly introduce my first 2 papers, how I make emotion detection model using AI. And then I introduced my last paper, how I apply this model to the real marketing application, in this case, donation behavior. So why we should focus on the EWM, the SNS? In nowadays, for example, in the tweet, over 500 million tweets posted per day in the internet, and they expressed their opinion about some brand, company, or service. So if marketer can understand their opinion to specific brand, then they can leverage their understanding opinion to forming the marketing strategy. But previous research, they usually focused on the sentiment analysis, means positive, neutral, and negative. So some people write something about a good review to the service and they think, oh, that's positive opinion, or that should be negative opinion. But human emotions are not that simple, just positive or negative. For example, anger and sadness is both negative sentiment. But when reader read a sad book, the left one, he expressed anger on the sad book, and right one expressed sadness on the sad book. Then left one should be a negative opinion. But whereas the right one, it should be a positive opinion. So even the same negative sentiment, in the specific emotion, they should be different. So that's why we should focus on more specific emotion than simple sentiment analysis. So I adopt the Ekman's 6 basic emotion, and he suggested people usually express 6 distinguished emotions: fear, anger, sadness, joy, surprise, and disgust. And this basic emotion theory is well known basic emotion theory, so I adopt this basic emotion theory to my papers. And why we should using the AI to analyze the SNS? Because, for example, if we wanted to analyze a million tweets and wanted to extract opinion, the specific emotion on that tweet, it should take 15 years by 18 annotators, and that's almost unrealistic approach. Whereas if I use my emotion detection AI model using the GPU single computer, it only takes 45 minutes to analyze a million tweets. So first paper, This paper objected to the human-robot interaction conference I present next month in Busan. And this paper argued that if we wanted to make a AI to understand human emotion, we should focus on two things: the big data, trained data, and the algorithm. So in terms of the data set, I collected the tweet that expressed a certain emotion. For example, in this screen, you can see hashtag joy. So I'm happy, hashtag joy means that user expressed a specific circumstance about he or she expressed joy. So I collected 5 million emotion hashtag by using the Twitter API. Then I trained several different machine learning algorithms, the traditional machine learning algorithm and deep learning algorithm, and recent the transformer algorithm. Transformer algorithm is also used in the ChatGPT, and this model learned all the books and the Wikipedia and so many the web page in the internet, and realized all the relationship of the English word. So we called that a pre-trained model. And then we used that transformer pre-trained model to train our own data set, tweet data set. For example, on the right side, I am happy, we trained that model. I am happy should be a joy, not a sadness or anger. Then we achieved more than 80% accuracy using our data set and the transformer model, and which is higher than the traditional machine learning model. That's my first paper. But still we have some problem issue. The second paper, the issue is that people doesn't feel same way as others. For example, in the baby stage, some baby feel when they see first saw the cat, they might feel sad or bored or frightened or happy. With the cat, that should be different. So how we can measure their emotion? I saw the cat, is it happy or joy or anger? So, but in the social emotional development stage, when they grow up, going to the school, they realize that most children actually feel joy when they saw the cat. So they got a pressure, social pressure. I must feel the same way with others. So we suggested to mimic the human social emotional development stage on the AI model. So we first trained the model with self-reported emotion, like a twist or other, some individual expressed their emotion, the large data set, like babies. And then we trained again with the annotator labeled data set, the small data set, but that data set already labeled with emotion by the human. It's used the same strategy like ChatGPT. So computer can learn by itself, but at the last, the human should give the answer to the AI. Then this model we called transformer transfer learning TTL approach achieved 84%, one of the highest accuracy in the emotion detection model up to date. So this is the sample. When you use the TTL model, for example, the good and bad news is something and good news is something, then this model detected the 6 different emotions. The joy is the dominant emotion, 22% with probability, whereas the surprise 25 or sadness 1%. So we use this different probability of the emotion as the mixed emotion variable. That's the second paper. And last paper, third paper, we used the TTL model to the real marketing application. So in this case, we analyzed the monthly donation behavior, the 10 years donation to the two different non-profit organizations, the university and the charity. And first we analyzed the 20 different famous brands in the US with these two non-profit organizations, and we found that using the correspondence analysis, actually these two non-profit organizations induce the joy emotion to the user. Means that when they think about a non-profit organization, they feel like I'm in the Disneyland drinking the Coca-Cola, something like that. Yeah, so these brands all induce the joy emotion, whereas Marlboro induce the sadness or disgust, or the tech companies induce fear emotion. And this is the result. First we analyzed the donation amount of the University of Auckland for 10 years. And we found that using the regression model, surprise, sadness, disgust actually had a negative effect on the monthly donation, whereas the anger has the positive effect. Means that there should be some surprise, but we analyzed the twist. We found that when people see some social issue like climate change or sea pollution, and they got upset, they feel anger, and that anger emotion actually motivate people to donate to the university to solve this issue, conducting research. So they are motivated with this anger emotion.
You have 2 minutes left.
Yeah. And when we analyze the 2 months, the last month, we include last month, we found that that effect is more the negative effect, become more stronger. And next one is the charity. And this charity offered eye surgery to the children. And we found that sadness and joy actually had a positive effect. Means that when people see the the children who need urgent eye surgery, they feel sad, and that motivate people to donate that charity. Or joy means when people see I'm happy with helping these children and with other usual donor, and they are motivated to donate more. But when we analyzed the rolling emotion, we found that anger became a new predictor, actually had a negative effect, means that negativity bias that can last longer than a positive effect. So this non-profit organization should be aware with the negativity bias when they manage the SNS post. Thank you very much, and this is the new approach to the marketing methodology, and I wanted to help or improve the marketing methodology in the future with my research. Thank you very much.
Okay, thank you. We can take one question.
Great. So thank you very much for your presentation. It's really interesting. And therefore, I have 2 questions. The first one, have you considered, for example, the sarcastic tweets that you could pull from Twitter? And the second question is actually how you manage to detect joy. Is it only using the joy word or other words? And there's another question, is that you consider the emojis, because nowadays there's some tweets that use emojis. So is there any code that translate the emojis into expressions?
So first question is the sarcastic one is actually that's difficult to realize the sarcastic twist. That's why we only achieved 84%. Means we cannot detect 16% twist accurately. So human emotion is not as simple. Maybe we can feel different emotion when you saw this presentation. So maybe 80% people feel same way, but 20 people feel different way. So that's why we cannot achieve 100% accuracy and 84%